Here we have a SAT math question. There is a system of equation over here. There is y equals to 3 times 2x negative a the whole square positive 1 and y equals to 6x negative 5. If x comma y is the only solution to the above system of equations, what is the value of x? In the only solution x comma y, we have to find the value of x over here. Okay, now let's solve the given system. For that, we have to write y equals to y. So for the y on the left side, we can use the expression that we have in the first equation, that is 3 times 2x negative a the whole square positive 1, and for the y on the right side we can use the expression in the second equation, that is 6x negative 5. Okay, now we have to solve for x in this equation. So for that I'm writing this 3 as it is. Now what I have to do is I have to expand the square of the binomial over here. So for that I'm going to consider the algebraic identity, that is a negative b the whole square. So its expansion is a square negative 2ab positive b square. Okay, now we can use this algebraic identity to expand the 2x negative a the whole square. So comparing this a negative b the whole square, 2x negative a the whole square, at the place of a we have 2x and at the place of b we have a. So in this expansion we have tried 2x at the place of a and a at the place of b. Okay, now let me do it. So a square means we have to take square for this 2x and we get 2x the whole square negative 2 times ab. So a is 2x and b is a. Positive b square means a square and positive 1 equals to 6x negative 5. Then we get 3 times. So when I evaluate this 2x whole square, it will be 4x square. Negative 2 times 2 is 4xa, or it can be written as 4ax positive a square. Positive 1 equals to 6x negative 5. Okay, now what I can do is I can distribute this 3 to this 4x square, 4ax and a square. When I do so, I'm getting 12x square negative 12ax positive 3a square positive 1 equals to 6x negative 5. Okay, now we have a quadratic equation in the variable x, but it's not in standard form. Standard form means it has to be in the form of ax square positive bx positive c equals to let me write it, equals to 0. So like that is, we must have everything on the left side. On the right side we must have 0. So here on the right side we don't have 0, we have 6x negative 5. So to make the right side 0, I have to get rid of the 6x and negative 5. So for that I subtract 6x from both sides, and also I add 5 to both sides. Let me finish. So then I'm getting this positive 6x, negative 6x will cancel, negative 5 positive 5 will cancel out. Then I'm getting 12x square, negative 12ax, negative 6x, positive 3a square. When I combine this positive 1, positive 5, I'm getting positive 6 equals to 0. Okay, now let me continue the stuff over here. So 12x square. Now these two terms are the greatest common divisor x. Actually, even it has the greatest common divisor 6. So I just consider only x as a great common divisor for these two terms. So x can be factored out. So now let me factor x out. Then I'm getting negative 12a, negative 6 times x, positive 3a square, positive 6 equals to 0. Actually, I factored x out from these two terms in order to get this equation, quadratic equation, the form exactly ax square positive bx positive c equals to 0. Okay, now instead of a we have 12, instead of b there is a coefficient of x is negative 12a negative 6 and c 3a square positive 6. Okay, so here the question clearly says the given system has only one solution, that is x comma y. Since given system has only one solution, even if I solve this quadratic equation over here for x, I'll be getting only one value for x. So if a quadratic equation has only one solution, then the value of the discriminant b square negative 4ac must be equals to 0, must be equal to 0. So because this quadratic equation has only one solution, usually when I solve a quadratic equation, I'll have two solutions because the degree of quadratic equation is 2. But here the given system has only one solution. So this quadratic equation also will have only one value for x. So the value of the discriminant b square negative 4ac is 0. Now we have to plug in the values for b, a and c. So b is the coefficient of x. In our problem, the coefficient of x is negative 12a, negative 6. Let me plug in that negative 12a, negative 6, the whole square, negative 4 times the value of a is 12, the coefficient of x square, c is 3a square positive 6 equals to 0. Okay, here when I consider the stuff negative 12a and negative 6, the greatest common divisor for this negative 12a and negative 6 is negative 6. So we can factor negative 6 out. If negative 6 factored out, we get 2a positive 1 inside the parenthesis and the whole square negative. When I multiply this 4 and 12, I'm getting 48 times 3a square positive 6 equals to 0. Okay, now, so here negative 6 and 2a positive are multiplied and we have the common exponent 2. So whenever two quantities are multiplied and we have the common exponent, the exponent can be distributed to each quantity and multiply the results. So then we get negative 6 the whole square, then 2a positive 1 the whole square. And also we can distribute this negative 48 to this 3a square and also this positive 6. So when I distribute this negative 48 to this 3a square, I'm getting negative 144a square. And when I distribute this negative 48 to this 6, I am getting, let me multiply it, 48 times 6 is negative 288 equals to 0. And when I evaluate this negative 6 whole square is 36. And so now we have to expand the square of the binomial over here. So for that, again, we have to use the algebraic identity. This time we have to use a positive with the whole square. So because between 2a and 1, we have positive sign over here. Its expansion is the same a square. But for 2ab, we have positive sign. Positive 2ab, positive b square. Comparing this 2a positive 1 the whole square and a positive the whole square, we get 2a at the place of a and 1 at the place of b. So in this expansion, at the place of a, we have to write 2a. At the place of b, we have to write 1. So let me continue the stuff over here. So then we get 2a the whole square, positive 2 times 2a times 1, positive 1 square, and negative 144a square. Negative 288 equals to 0. Okay, now let me continue the stuff over here. So 36 times, so when I evaluate this 2a the whole square, it will become 4a square. Positive 2 times 2a times 1 will become just 4a, then 1 square is just 1. Negative 144a square, negative 288 equals to 0. Now we can distribute this 36 to 4a square, then I'm getting 144a square. When I distribute this 36 to positive 4a, I'm getting 144a. Positive 36. When I distribute this 36 to 1, then we get negative 144a square, negative 288 equals to 0. This positive 144a square, negative 144a square will become 0. Then we get 144a. When I combine this 36 and 288, 36 and negative 288, I'm getting negative 252 equals to 0. Okay, now let me add 252 to both sides to solve for a. Okay, let me finish. So this one will cancel. I'm getting 144a equals to positive 252. Now I divide both sides 144. When I do so, this 144 cancelled. A equals to, when I divide this 252 by 144, I'm getting 1.75. Okay, now I got the value of the unknown constant a, that is 1.75. So now what I have to do is in this equation, I have to plug in a equals to 1.75 over here, and then I'll be getting quadratic equation, the variable x. So then I have to solve for x. Okay, now let me erase all the stuff, and I'm going to plug in a equals to 1.75 into this equation. Here we have the equation, and also we have the value of the constant a, that is 1.75. We can plug in a equals to 1.75 into the equation over here. Then I'm getting 12x square positive negative 12 times 1.75 negative 6 times x positive 3 times 1.75 the whole square positive 6 equals to 0. So 12x square. Here when I evaluate this numerical expression, I'm getting negative 27. So when I multiply this positive and negative, I'm getting negative 27, and here we have x, so we get negative 27x. So when I evaluate this expression, that is 3 times 1.75 the whole square positive 6, I am getting positive 15.1875 equals to 0. Okay, now we have a quadratic equation. So I think it's a little time consuming to solve this quadratic equation either by factoring or using quadratic formula, because we have a decimal value over here. So better we can go to Desmos graphing calculator and solve this quadratic equation. Okay, now let's go to Desmos graphing calculator. Here we have Desmos graphing calculator. Now we have to give this equation as input over here. Okay, now let me type the equation. That is 12x square negative 27x positive 15.1875 equals to 0. Okay, now I have given the equation as input. Now I have to see where the graph intersects x-axis, that's called x-intercept. So clearly the x-intercept over here is 1.125, 0. In this x-intercept, we have to consider the exponent over here. So that's a solution. That is x equals to 1.125. So already we have known that so x comma y is the only solution for the given system. In this only solution, we have to find the value of x over here. So the value of x is 1.125.